Right, can you guys hear me? All right. Welcome, everyone. I'm Santosh Bardwaj from Discover Financial Services. So I lead our advanced analytics team at Discover, which is basically working on building a brand new next-generation modern data ecosystem. Pretty excited to be here. Honestly, I heard this talk this morning, and I've been on this journey with Hadoop and big data for the last 5-6 years now, both at Discover and my previous stint at Capital One. It's pretty amazing to see how this whole technology has evolved over these years, and not just Hadoop as a technology itself, but really the overall ecosystem. But it's pretty exciting as a technologist, as an organization that's trying to adapt this and push for enterprise adoption and really monetize on these capabilities. Sometimes it can be pretty confusing and frustrating too. I keep reminding my team every single day, there are frankly no easy buttons out here as we go down this journey. I'm sure you see a lot of flashy demos on laptops and others. When we talk about really scaling these capabilities across the enterprise, and especially a financial services organization, where we are really scrutinized by regulators, and we got to make sure that we demonstrate that we are well-governed, you can't just pick an open source tool out there and just expect this to scale and adapt to the enterprise. Which really goes into the theme of today's talk is really about how we as an organization, we've been down this journey for the past few years, and sort of the approach and some of the philosophy we have taken in terms of taking these open source tools, taking some of those features that we get out of the box, and really engineer them, customize them, and expand them before we push them to the enterprise for adoption. So the agenda for today's talk is really about one of the core components of this ecosystem, which is our data pipeline. So at Discover, we've been managing a very mature data analytics stack for many years, quite frankly, many decades now. And one of the things that we wanted to address as we went about this journey was really three things. One is to make sure that we continue looking at taking all the great things that we had operating an enterprise data lake in the past, an enterprise data warehouse, and really using those enterprise capabilities to continue with that. But really move us away from a really batch-centric, sort of a once-a-day kind of a paradigm to something that's more real-time in nature. And the third philosophy from a technology organization that we intentionally made a choice to say we are going to be increasingly biased towards open source technologies. We're going to be going with an open source first mindset, an open source first mentality as we build this. And one of the key things we believe as a foundation that really sort of ties this whole ecosystem is what we call our data pipeline, or the data plumbing. So what I'm going to talk about and be sharing over the next 30 minutes is really about how we went about building this new data pipeline using technologies like NIFI and Spark, not just to ingest data, but also to be able to ingest, aggregate, process data, and deal with a variety of complex data formats that we had to deal with along the way. And obviously, as we were pushing for enterprise adoption, there are a bunch of complex use cases that we encountered during the journey. And what are some of the things we really like about NIFI that allowed us to customize those capabilities? And it's kind of really talk about really the end state and the vision of where we see this platform going. I think I have about 20-25 minutes of content. I make sure we have about 10-15 minutes towards the end for Q&A. But if you really have an urge to ask a question, feel free to stop me. But hopefully I'll go through the content real quick and make sure we have enough time to have some conversation. So I'm sure many of you are familiar with Discover. Apart from being one of the largest credit card issuers in the US, we also have an international presence across 180 or so countries using with Diners Club. And in addition to credit cards, we also have other lines of business in terms of payments, in terms of student lending and deposit platform. So one of the things that sort of makes Discover great in terms of brand loyalty, we've consistently been ranked as #1 in terms of brand loyalty in the credit card space for the last 21 years, is behind the scenes, we use extensive data and analytics for every interaction that we have with a customer, or every decision that we make that impacts our customers. So again, as I said, we've been operating a pretty mature data analytics stack for more than 10-15 years now. We had this notion of a data lake even before data lake became famous, except that the data lake was predominantly used to store a lot of raw data. It was not consumable directly, but we had all the raw data stored in the data lake. We had a pretty mature ETL grid that would transform this data, make this data ready for consumption on a data warehouse, and all the analytics center of excellence that would unite all our users around this. But we also saw the world changing as a financial company. And again, Discover is a direct bank, which means we don't have any branches. So all our interaction with our customers is mostly through digital channels. And again, with the advent of the smartphone and sort of the phone being sort of the personal preference of choice in terms of how you interact with banks and financial services, over the last few years as a data entity within the organization, we realized that there was a huge surge in the amount of data that we had to deal with. All the way from ingesting all this data, making sure that we are processing this data and making this data available for consumption. And the other thing that was also changing within the industry was really our changes in customer preferences, where increasingly our customers are expecting a more personalized approach in terms of how we interact with them, but also a very real-time approach in terms of how we interact with them. So that basically was sort of the genesis in terms of why we started working on really modernizing our pretty well-run, mature analytics stack into something that's really suited for the real-time era. The very first thing that was part of this whole ecosystem is we wanted to bring all the data in one place. And not just bring all the data into one Hadoop data lake, but also bring the ETL processing that we were doing on a separate grid as part of this data lake, and bring all the analytic tools along with this. So rather than having 3-4 siloed platforms where you had data moving crisscross between these, we wanted to, as far as possible, sort of bring all this data and the processing and bring them close together on the unified data lake. And the second thing that is, again, as I said, which is the theme of today's talk, is really the data pipeline. This was our moment, really. We wanted to kind of reinvent in the way we kind of look at data, look at processing. We want to take this opportunity to fundamentally move us away from this once-a-day batch, 24-hour cycle into something that is more continuous in nature. And continuous not just in terms of data feed, but also be able to ingest data from a variety of different data sources. Predominantly, if you look at our legacy stack, most of our data ingestion was through flat files. We want to get to a place where we had the ability to start ingesting real-time events. And in addition to that, when you bring all your data together, when you have a pipeline or a plumbing that sort of weaves this, additional capabilities that allows our users to do more stuff like AI, machine learning, streaming analytics, extending this platform to the cloud. And overall, again, at the end of the day, our goal is to see how can we monetize on this platform. This is not just a science lab that we were standing up. We had really an enterprise view. We wanted to kind of move our analytic capability and the decision capability across the enterprise into this ecosystem. So how do we sort of monetize this and truly move our business capabilities from being able to respond and react from days and hours to be able to do that in minutes and seconds, really a speed to market play. So we started working on this unified data ingestion platform about a year or so ago. We call this data flow internally. So essentially, one of the key sort of attributes of this data ingestion platform is the ability for us to be able to ingest data in a real-time and a continuous manner from a variety of data sources, agnostic, whether it's internal, whether it's external, whether it's file-based, whether it's event-based, whether it's databases, agnostic to what the data source is. We wanted to have an ability to be able to ingest all this data through an enterprise reusable service rather than having a lot of point-to-point solutions. So I'm sure many of you guys are familiar with Apache NiFi, and the reason we picked NiFi as a technology is because fundamentally, what is NiFi? It is basically a technology that allows you to do automated data flows from a producer to a consumer. And the great thing about NiFi is the ability for it to be able to orchestrate these data flows in a more automated fashion. And some of the things we really like about NiFi, as to why we picked NiFi as our foundational choice behind this platform, is it's scalable. Again, if we are viewing this from an enterprise lens, we wanted to make sure this is something that can scale across the entire organization. But really, the thing that we really liked about NiFi is the ability for us to customize. And I'm going to showcase a lot of examples during the course of this content to show some of the customizations that we have done. Just in the last 1 year, the engineering organization has done a lot of in-house customization. The other thing that we had to demonstrate was, again, keep in mind that we were working on this platform. We wanted to make sure this is at least on par, if not way better, order of magnitude better than sort of the mature legacy ETL platform that we had. And one of the key things that we as a financial organization have to demonstrate is good governance. And that's one of the things that NiFi has, is the ability for you to have a data lineage and data provenance. Okay. The third thing was really promoting reuse. So Discover is increasingly operating in an agile manner. In fact, even our own data analytics organization right now is going through the journey where we are, rather than having centralized teams, doing data delivery, we're moving increasingly into where, all these data engineers, the data delivery folks are being moved into product squads. So for that, we wanted to have a mechanism where we just don't go wild and everyone starts reinventing the wheel, and before you know, have 10 ways of doing the same thing. So we wanted to promote reuse, right? So we wanted to be able to sort of stay aligned as an organization, but still allow these agile squads to operate autonomously. And that's one of the other things we really liked about NIFI, and when I show the examples, you'll see some of the things where we have really established reusable patterns for the enterprise to use. Okay, and the last thing is really around sort of the UI and the drag and drop. That's a huge hit. So a lot of our folks, more than half of my team that's in the data engineer were ex-ETL developers. Have been working on tools that had this drag and drop interface, the flow-based programming. And yes, you can hand code your way into a lot of these things. But again, when we were thinking of enterprise push, we were really looking to say, how can we really scale this? And one of the things that NIFI really allows us to do is sort of the whole UI and the flow-based programming methodology. So this is kind of a compare and contrast between where we were and where we're headed. So the top piece probably is very familiar with a lot of traditional organizations in terms of how we have been running our data pipelines and our data factory for all these years, right? So we have this operational databases where you get this once-a-day file extracts. In our case, we had sort of this data lake where we were storing all this raw data. The raw data was not available for consumption. It was out there available. We had years of history sitting on it. You would have an ETL engine out there that would do all the data munging and finally be available for use in a warehouse. By the time this whole cycle went through, it would take us about 24 hours. Now think of it from a banking perspective in terms of some of the challenges we are facing, like examples like fraud, right? Obviously, the fraudsters out there are getting increasingly creative. Every other day you see news about these major hacks. And think about if we have a cycle where it takes us 2 to 3 days to get this data and analyze, the fraudsters have moved on to something new. It's done. It's stale data. So we want to really move to a paradigm where it doesn't take us 24 hours or longer to get this data available for consumption. We want to really make sure that this data is available in minutes and seconds. So the bottom is really sort of what we have built, and we are continuing to expand. The adoption is the data flow platform, which is built on NIFI and Spark, basically gives us the ability for us to ingest data. In the top half, 90% of our data sources in a traditional system are flat files. So we wanted to kind of fundamentally change that, where our increasing preference for data consumption is our event bus, our enterprise event bus. Many of our operational systems are publishing events, and we want to be able to literally in seconds be able to ingest those events into the lake. The other thing that we are also doing is kind of expanding the range of data sources that we can ingest, and not just internal, but also be able to ingest some of our external data sources. And there are two things that I'll sort of touch on during the course of this talk is around how we wanted to make sure that we reduce the data latency by going towards a true sourcing approach. I'm sure many of us who went down this journey in the beginning, you probably all have scooped your data from your warehouse into Hadoop. And that works great, right? Initially when you're doing POCs and prototypes and you want to have a quick way of getting your data, that's a great way to bring your data in, is to be able to scoop from your operational databases, scoop from a data warehouse. But again, there's the latency that's built into it. So what we have done is we started down that path initially when we were doing these initial prototypes, but we have quickly moved to an approach, what we're calling true sourcing. So when a data gets published at the source, literally instantly within minutes, we want the data to be available. And the second piece of it is real out, how do we take this raw data, enrich it, and make it available for consumption? And I'll talk about some of the complexity. This looks great on this picture with these two boxes and these two arrows. So during the course of the slide, I'm going to start unraveling and peeling the layers about some of the complexity that you actually start figuring out behind this simple arrow marks between box 1 and box 2. The other thing that we are also doing is, as we are extending our data lake into the cloud, into a hybrid architecture, we are continuing to look at how we can push the capabilities of NIFI and the whole data flow platform, not just to be an on-premise solution. We really want this to be agnostic to where the data is, which means whether it's in the cloud or cloud provider A, B, or on-premise, we want to have this single platform to be sort of a hub and spoke model to push data to all the different consumers. All right, so let's go and get into a little bit of details here. Again, as I said, one of the things we wanted to demonstrate as we were building this ecosystem, we took an open source first approach. But given that we are a financial services organization, we also had to demonstrate to our internal auditors, we had to demonstrate to our regulators saying that just because it's open source, it doesn't mean we are less governed, right? We are as mature and as methodical in the way we handle data. So the data basically flows through 3 different stages in our data lake. The first is our system of record. So that's where all the raw data gets stored. It's quarantined, people don't have access to it, so because some of the data may have sensitive data in it, and very often when you get data, you don't know what the contents of the data is. So this is a place for us to at least have all the data in its pure, pristine fashion out there available for use in later. But quickly what we do is the very next stage is where we take this data that is in the system of record, do some light modeling on it, some very light ETL, obfuscate any sensitive data, and move this to the source of truth. So all of a sudden, you have your raw data with all those 4,000 attributes available for consumption by a pocket of users. You can have some senior data scientists out there who can start looking at this raw data that's consumable, queryable, right, and figure out, okay, what are some of the attributes out of this that actually make sense to me? So if you really think about how we used to do it in the past, that used to be a huge ordeal. This was something you needed to have an IT project and get in the queue and get an army of ETL developers, BSAs, data analysts, and a whole quorum of people to figure that out. What we have basically changed is now we actually have opened up this raw data available for consumption. And the final stage is really where this source of truth gets into the next stage where we are truly enriching this data with business logic, with business transformation, business metadata. So the vision we have is really, we wanted to move away from this stop and go approach to make this whole thing a continuous flow. So irrespective of all the complexities I'm going to show right now in the next few slides, we want to make sure that we still kind of maintain this sort of the real-time first approach and make sure that we, as far as possible, all these customization we're doing in is built into those NIFI flows. So this is another layer where I'm now starting to zoom the microscope to start showing some of the complexities we have here. I'm not going to walk through every one of these boxes, but behind those 3 big boxes that you saw, the source, from all the way from the system of record to the source of truth, these are all the different stages that the data has to go through. So once the data lands, you got to make sure you're cataloging this data. You got to make sure that your data is converted to a format that is sort of consumable. Apply a schema on it. So at this point, you have your raw data that's available for consumption. It has to go through all the metadata information, both technical and business metadata, go through all the data quality checks and all the business enrichment logic that you have to put in it before it's finally ready for consumption. In addition to that, the other thing that we also took into consideration when we were building this platform are all those horizontal boxes that you see at the bottom. These were almost foundational to this. We got to make sure that we have robust monitoring in place, the ability for us to reconcile any data mismatch, have great governance. And one of the things we also wanted to do is sort of move us away from a very reactive approach in the past, something that's more proactive and kind of real-time in nature. But to just give you an idea, this is sort of some of the complexity we started running into as we moved beyond our initial set of use cases. And one of the first things that we encountered were these complex data file types or data formats. Internally, we fondly call them these exotic data types. Again, if you look at any organization, you have a mix of both. When we started down this journey, I would say probably half of our data was relatively simple in nature, so which means a lot of the out-of-the-box features and capabilities that we were getting out of tools like NIFI and Spark was mostly OK for us to do basic ingestion. But right now, we are really starting to push the envelope in terms of enterprise adoption, which means we are really taking some of our most critical business capabilities within the enterprise and moving this. So which means we had to start dealing with these complex data types. So here's an example of one of the examples that we encountered. So this is an example of where we actually get a data file where the length of these records can be dynamic in nature. Okay, so most of these have sort of almost a logic built into those data files. So in this particular case, so if you look at the very first example, so basically what it is, it's collecting household information from a customer. So it's basically saying customer name, age, and how many siblings do you have. Now, the customer number 1 has 2 siblings, right? So he has his 2 siblings, Susie and Chris, and the city name. In this particular case, city is column number 6. Now, if you look at customer number 2, he has 3 siblings. Now, all of a sudden, city now moves to column number 7, and so on. So if you think about it, and once we start dealing with these complex data files and these data formats, it's really not straightforward for you to say, okay, Hive, just go ingest this stuff, because Hive doesn't know how to view this stuff. Because in some cases, you may have city sitting in column number 4. In some cases, you have the city sitting in column number 8. So there was this dynamic nature of this. And to add to this, there were also these additional layers of complexity where we had this nested arrays or struct data types. So that's a second example of where we are collecting information about the customer in terms of all the different jobs he has worked at. So, and again, that's an array size that can vary, right? In some cases, a customer may have worked in one place. In some cases, a customer may have worked in 3 places. So, and this is just one of the few examples. That there are many more such things where essentially what it is we have these complex data types where you just cannot look at it. Although the information is coming in pipe delimited form, you just can't predict and say, okay, column number 4 is this, column number 5 is this. And this was probably our hardest problem that we had to encounter because there were no out-of-the-box solutions out there to deal with it. And I think one of the great things that some of our traditional ETL tools, which many of you probably use, is their capability for them to deal with all these different data formats and these different data layouts. And essentially what we were trying to do is take an open source technology like NIFI and Spark and see how can we sort of match those capabilities that we were getting with these tools. So basically, this was our solution. The way we kind of solved this problem was create a custom NIFI processor where, and I have another slide that kind of shows the flow in the next slide, where when we get a raw data, we basically apply a schema on top of it. The schema has the logic to be able to interpret the contents of this data. And we have a schema converter basically written in Scala code and Spark, which takes this, applies a Spark schema on top of it, and converts the data into an Avro file. So once the data is available in Avro, now it can be easily ingested into Hive. You can convert it to JSON and move this file anywhere else if there are folks outside the lake who want to consume it. And this is actually one of the great things we really liked about NIFI was the ability for us to customize it. I mean, I've lost count in terms of how many custom processors we have created as we've gone down this journey. And again, I talked about the reusability. Now that we have built this, so tomorrow if there's someone in the enterprise who says, hey, you know what, I want to ingest data from the mainframe that's sitting in episodic format, and how do I do it? There's already a reusable pattern available for them to use.
What are the custom processors you wrote in Java, Python?
I think it's a combination of, yeah. And that's the other thing that's great about NIFI is the flexibility. You're not restricted to one language of choice. I mean, it can be Python, it can be SQL in some cases. This is basically kind of what I was talking about in the previous slide is like, you look at this raw data that we store in a system of record. All it is just in some cases, a binary format, or some cases, it's just a lot of gibberish in pipe delimited form. So, and when we talked about we were trying to push our data scientists to say, hey, guess what? We're opening up this raw data lake available for use. And the example we have commonly used internally is the sort of the salad bar is, hey, we've opened up the salad bar now. Right? You can consume all of this. You know, you can't make sense out of it. Okay, so very soon we realized that we had to really make this raw data into some kind of a consumable form for people to be able to query it and people to be able to do analytics out of it. Okay, and most of these raw data files typically come with a schema, and this is really in a proprietary form that our traditional ETL tools provide. Now, as we were migrating sort of the workloads from a traditional ETL tool to NIFI, we had to basically convert this from a proprietary schema into something that can be interpreted by NIFI and can be consumed in the lake. So the next step is we convert this into a JSON format, and next it gets into a Spark data frame schema, and by the time it's done, you have this data sort of ingested. So now the table that you're seeing there, this is something that's consumable by people. People can query this information. Right? In fact, there is sort of a drill down. I couldn't show this on this slide where you have those nested arrays, and you can actually see all the information if a person has worked in multiple cities. So this is probably one of the greatest sort of value add for us was really opening up a lot more data available for users. Because in the past, again, given the cost of some of these proprietary warehouse platforms, we were constrained in terms of how much data, how much of depth, how much of history that we were making available to our users. Now with the Hadoop data lake, and using some of open source tools such as NIFI, now we have basically opened up the whole data universe out there for people to be able to consume. In fact, there have been many use cases where all of a sudden our tables have moved from like where we had just 100 attributes to now we have all the 4,000 attributes available. And that's been immensely helpful for people to be able to gain more insights. The other thing that's been frankly quite surprising just for me is, when we started down this journey, we were a bit skeptical in terms of how long it would take for people to learn NIFI, how to learn these new technologies. Again, I think I told you, like more than half of our team were, ex-ETL developers who were able to pick this technology literally within weeks. This is a great example of actually one of our engineers truly in an agile fashion, sort of work in an iterative way to just keep making this better. We had a use case where we had to ingest data from an event bus. Our very first iteration of it was, again, we still had the batch approach to taking things. We said, OK, we'll consolidate all this data coming from the event bus, move it to a file, and bring it to Hadoop using a NIFI flow. So those are our baby steps when we started on this journey. Well, that's great. At least it demonstrated that we could build a flow in NIFI, but it really didn't meet our needs because it was still taking us about 24 hours to bring the data. So we went to the next step where we built in a bunch of customization, to the best of our knowledge. It sort of worked, but it was pretty complex, and it had limited scale, it had limited reusability. And sort of the third iteration of this is where we truly developed a custom NIFI processor to be able to ingest this data from the event bus. And this is something that's a reusable pattern that's available out there. So if there's another use case within the organization who wants to ingest data from the event bus, we already have a processor available for it. And I think that's probably one of the greatest things that NIFI has really shown is we almost are maintaining a library of these processors right now. So if you're a data engineer sitting in an Agile squad out there and you have this use case to ingest data from source X, you can actually find a processor available for you, readily available in the library. So once we went from the ingestion phase, so there's a second phase of it, which was really our Enriched phase, which was our enriched sourcing. This is where we make this raw data available, raw consumable data, into truly enriched, where we're putting some logic into it, some sort of business metadata into it, so a larger population of users can consume it. And this is where you actually have to do some pretty heavy-duty ETL work. Okay. I wouldn't say NIFI is probably the right choice for that, right? We are trying to still see how we can extend the envelope of NIFI, and this is kind of where we fell on Spark as a tool of choice to be able to do those, hardcore ETL work. A few months ago, this was one of our projects which had a decent number of jobs, over 600 or 800 jobs that they had to convert. They were migrating to Hadoop. The very first iteration of it was we continued using our traditional ETL tool, which means we are ingesting all the data from NIFI into the lake. We are pulling all the data from Hadoop into our ETL grid, processing it, and bringing it back into Hadoop. It worked, but it was painfully slow. It was taking us, like I say, like 18, 20 hours to run these 600 jobs. And we were making all these promises to business to say, hey, this is going to be faster, better, and out here we were still taking 18, 20 hours. So this is not going to work. So we said, OK, let's figure a way for us to start doing some ETL work natively on Hadoop. And we were still building this data flow platform. So we said, OK, let's go and start doing this ETL work on HiveQL, which certainly helped. It really cut our time down by half. We literally refactored all those 600 jobs from our traditional ETL tool and rewrote them on Hive. But again, our goal was really to, we were making this whole promise of being able to get data available in minutes. So even 8 hours is too long. 8 hours is better than 24 hours, but it's still not nearly close to sort of the minutes that we were promising. So the final iteration of it, and this is actually one of our engineers who really took the initiative to say, let me look at the code and see why I can convert this to Spark. And within, I think, course of 4 to 5 weeks, we had refactored every one of those 600 jobs from HiveQL into Spark. And that's cut down our time down to an hour. I know as I speak right now, the team's continuing to tune those code, just learning to be more adept at writing Spark, Scala code. I'm sure that will get down to minutes. What we are working on right now is really about the way we develop this Spark-based ETL right now is still predominantly hand-coded. We have a handful of engineers who are very well versed in Spark, right? And they have the ability to be able to hand-code this. And again, when you put an enterprise hat to say, this is something I really want to roll this across the enterprise, across all these different data teams, I don't think hand coding is the way for you to scale things. You need to have a tool, an automated tool, and that's one of the things I talked about NIFI as being an advantage. So what we are working on right now is really to say, how do we take this sort of this hand-coded approach and put this into more of a flow-based mechanism, so people can, again, continue the whole evolution of the data from the ingestion to the aggregation and the processing in a flow-based manner. Okay, continuing to test what we can do with NIFI, but actually working on other options in terms of how we put Spark into more of a flow-based approach. So we have a lot of plans, in terms of sort of realizing our vision, in terms of really constructing this as not just a data pipeline for the Hadoop data lake, but eventually we see this sort of extending this into the real-time paradigm as well and creating a sort of a data loop between your real-time and the batch. And that's the part we are working on right now, is how do we integrate these two? I mean, right now we have two separate pipelines that's feeding data into the real-time. There's another pipeline that's feeding into batch, and we want to be able to integrate this. We're going to continue working on how we make more custom processors out there to solve some of these exotic use cases that I talked about. We have had great success in sort of integrating data quality into our flow. In fact, we use a third-party tool for DQ, and the great thing about NIFI is it issues a REST call to this tool. It comes back with a return code, and literally in seconds. And think about sort of the improvement we have made is in the past, data quality was something that was an after-the-fact thought. You would ingest all the data, and you would have a DQ engineer who would go there and look at all these data qualities. You had to go back and address it. Right now, data quality is part of the flow. I mean, it is, as you're ingesting the data, your data is actually getting addressed right there and then, and your data is getting cataloged, and you're building the whole lineage around it. The other thing that we are also working on is how do we make this platform more self-service? So rather than, again, relying on your data engineers to be able to bring data, for some portion of our data, we want our analysts and users to be able to, in a self-service manner, bring their own data, kind of almost a DIY pipeline. And again, I talked about the main thing is how do we sort of integrate that batch and the real time into sort of one cohesive sort of a data loop. Yeah, so those are the contents. That's what I wanted to share. Again, as I said, it's been quite challenging and complex, but again, as a technologist, as an engineer, I enjoy this. We've learned a whole lot. Looks very promising. Thank you.